All right, so let's try these problems right here. So, no calculator would be the goal on this. But Noah, you asked a question when you have to hit second sign or inverse sign, right? This would be when you don't, right? If this was calculator, you just cosine 5 pi thirds, you just type it. And I'll show you one where you would here in a minute. But these would be no calculator. So on Thursday, there could be a section where I ask you this on the no calculator part. So try those. There's the first one. So remember, when we're doing them without a calculator, one way is for the unit circle, and another way is with triangles, and they're closely related with triangles and reference angles, right? So I drew it as a triangle scenario, right? But if you think your way around the unit circle, if you're pretty good with those values, you can probably just think your way around there and maybe get it that way. But I just drew it as I was thinking, okay, 2 pi, that'd be 6 pi thirds, so 5 pi thirds would be short of that by a pi third, which is 60 degrees. So that's a 60-degree reference. 60 degree across from 60 is 3 over 2, across from the 30 is the 1/2, that's negative because it goes down. Cosine would be the x, so 1/2, right? So reference angles, so using reference angles and triangles can be a way to do it. But also think about, but also if you were thinking about the unit circle down here, what would be the coordinates? The coordinates be, if you looked at your unit circle, the coordinates of that point right there would be 1/2 negative root 3 over 2. So cosine the x, sine the y. Okay, next one. Either one of those would be okay to have. But again, negative 7 pi 6, so that would go this way. Pi would be 6 pi 6, so one more would be 7 pi 6. So that's a 30-degree reference angle right there. 30 degrees, cross from 30 is 1/2. You got that, you got that. So if you got those 30 60s down, you got it. Tangent is the opposite over adjacent, the y over the x. 1/2 over root 3 over 2 would be either one of those. Okay? Pi halves is 90 degrees. So think of the unit axis then. Think of the points, the 0, 1, stuff like that. That's the best way to think of that. Cosecant is reciprocal of sine. Sine is the y, so reciprocal of 1 is just 1. And then negative 3 pi go around 2 pi, and another pi would take you to there, which is that point. Sine is the y. So sine is the y. Okay? All right. Now, this would be, so we were talking about the calculator, and I think we're going to move on. Oh no, we are going to use a calculator, so no, we'll get to that then. Okay, solve these from 0 to 2 pi. Find what theta is. That says solve, but this is no calculator. Sorry, everybody's grabbing their calculator. We're going to do a calculator in a minute. This is no calculator, right? This is just the reverse, though, of what you just did. It's no. But it's like an equation. We're trying to find this unknown here, so we're technically solving, but it's just a reverse, right? Last time I gave you sine of negative 7 pi-thirds or whatever, well, I don't remember what it was. You drew the angle, got your triangle, and found out what the triangle parts were. Now I'm just showing you that, giving you the triangle parts, you figure out what angle goes with it. It's just the same question, just in reverse. Okay, finding the other part of it. Okay? So it kind of goes back to the quadrants. What quadrants would you draw the triangle in? And I'll give you a hint right now. There are two solutions. There are two different quadrants where sine is negative. That's where you should draw your triangles. Oops. Okay, so let's talk about it here a little bit. So again, when you get to this, when you get to one like this and it's no calculator, the question you ask yourself is, okay, where does sine, what angle has a sine that's negative root 3 over 2? Well, if you look at the unit circle, that's like asking, where is the y negative root 3 over 2? Well, there's one right there, and there's one right there, right? That's why there's two solutions between 0 and 2 pi, or 0 and 360. Where does sine equal negative root 3 over 2? Well, if we've memorized the unit circle, it's at 4 pi-thirds, and it's at 5 pi-thirds, right? It's at 4 pi-thirds, so when theta is 4 pi-thirds, and when theta is 5 pi-thirds, should be our solution. Now, how would we work it out? I think if you some of you, I noticed a couple people actually wrote on their quiz the unit circle and wrote it out. Took the time to do that. Now, if you have time, that's fine. Okay, if you do that, then you've got it kind of there in front of you. Okay, but if not, you can just say, okay, I need sine. Sine's the y, right? It's opposite over hypotenuse, but I can draw it as a triangle. Also, I recognize that's one of my special values. That's one of my 30-60 situations. So where is sine, the y negative? Well, it's going to be down here and down here. And sine is the y, so negative root 3 over 2 and negative root 3 over 2. Put the rest of it, but right away that tells me, oh, that's a 60-degree reference. That's a 60-degree reference because that's across from the negative root 3 over 2. And then I just got to count. Okay, 3 pi-thirds, 4 pi-thirds, and then 5 pi-thirds. And then around here would be 6 pi-thirds. So that's 4 pi-thirds, 5 pi-thirds. Okay, what about tangent is 0? Well, tangent is sine over cosine, right? That's one way to think about it. It's y over x. So a fraction is 0 when what? When the top is 0, right? So if tangent is 0, the way I'm thinking of this is I'm thinking of this as sine over cosine, or I'm thinking of this as y over x, and I'm thinking, well, the y has to be 0. For tangents to be 0, the y has to be 0. Well, where is the y 0? At those 2 points right there. at those 2 points right there. That's the thought process. So without a calculator, that's the thinking you have to do. There's no shortcut. That is the shortcut, right? Is memorizing those things and knowing them. Okay? Now, if we had a calculator, yes, that's when we could hit second sign, and we're going to do that. Matter of fact, you could do it right now. Go ahead and try it on your calculator. Second sign. And do second sign of negative root 3 over 2. And hit enter. What does it give you? Now, but this is where you're going to see the calculator is not the magic thing there, because the calculator is not going to give you 2 answers. What did it give you on this one? Matter of fact, it didn't even give you the answers we had. What did we say? 4 5/3 and 5 5/3? Now, you guys did it, I know, in degree mode, which is fine, but that would be, that'd be 240 and what? 300 in degrees. Did your calculator give you 240 or 300? What did it give you? Gave you negative 60. Well, that's this one, isn't it? That's this one right here. And we're going to talk later on of why the calculator is giving you negative 60. But it's giving you that one. It didn't give you this one. And since our answers are supposed to go from 0 to 2 pi, negative and a negative answer is not going to work. So you would have to write its coterminal, but you'd have to understand that, so even with a calculator, you've got to know this quadrant business. Okay? All right. So there's 2 answers. All right, 2 answers here, 0 and pi. Now on this one, I think if you do second tangent of 0, it gives you 0. Okay? But pi is another one. Pi is another answer. Okay? Why wouldn't we include 2 pi? Because you go 0, then pi, then 2 pi gets you back to here. Why don't we write down 2 pi? Right? Because we don't include that because it's the same as 0. So we don't. Okay, now use your calculator. So here's where you go second. So no, I think that was your question earlier, right? When do you use second inverse cosine or sine? So now you go second cosine or inverse cosine negative 0.3418. And what's it give you? In degree mode, what's it give you? 109.986. 109.986? Yeah, it's called 110. Okay? Okay, so 110 degrees. Okay? Now, that's not the full picture. Okay, there's 110 degrees right there. Okay? That's one answer. What other quadrant are we in? Where is cosine negative? Quadrant 2 and quadrant 3. So that means we'd have another answer down here. Now what is that? Well, here's where reference angles come in. If this is 110, what's this little guy right here? 70? So doesn't that mean this would be 70 right here? It would. And so how much is that? So 110 is one answer. The other answer? 250. 180 plus 70. Right? Reference angle, because reference angles are always here with the x-axis. So the calculus, so we haven't done a lot of that, and that's why I'm doing these now, and then we're going to do some more tomorrow. There'll be a few of these on the quiz, or on the test on Thursday, okay? But that's because that's using your reference angles, using the idea of quadrants, because that's what that's saying, where cosine has negative outputs, right? Is in the third and the second quadrants, okay? And we use the idea of reference angles to get those 2 answers. And we want them in degrees because it said 0 to 360. Okay, so let's do this problem. This is from your book, number 26. This is kind of a hard one. You're gonna have a lot easier ones. Now, I take it back. Let's step back a minute. Let me see. Let's do homework questions here first. Somebody mentioned 32. Okay. Was there another one? 23. Okay. So 23 says, from a point in front of a church, 50 feet in front of a church, the angles of elevation to the base of the steeple and the top of the steeple are 35 degrees and 47 degrees, 40 minutes, respectively. Find the height of the steeple. So, anybody know what a steeple is? Kind of the, top point on the, bell tower, whatever. It could be a lot of things. So in other words, what you have is you've got to there, and then to there. All right. There's the steeple right there. Okay? So, and it says from a point 50 feet in front of the church, so this would be the 50 feet, and the angles are 35, so that would be this angle here would be 35, and then this angle here is the 47 degrees, 40 minutes. Okay? Find the height of the steeple. So, it's probably, do they give the height of the church? From a point 50 feet from church. Oh, so this is a little bit like some problem we're going to do here in a minute. But so the height of the church would be the x, and then you'd have the y. Okay. So since we know both these angles, what trig function? Let's do the x first. So what trig function are we going to use? Tangent. So we got opposite over adjacent. So we use tangent a lot, we use tangent a lot because a lot of times in these real life kind of problems, we're not that interested in the hypotenuse that often, okay? But sometimes we are. So tangent of 35 degrees is equal to x over 50, right? So that's pretty easy. You're just going to multiply 50 times tangent 35, right? And what do you get? 35.01. Okay, let's just as a default, let's go 2. I know I talked about 3 earlier, but let's just go 2 if it doesn't say any different. Okay, we'll go 2 decimals. Okay, 35.01. But remember, if we use that, we should use more later. We'd like to stay away from the rounded values, but we may not be able to always, because that's what's happening in this situation. So now if we do tangent of 47 degrees 40 minutes would be the 35.01 plus the y, right? Like that. And that's where we can't really probably avoid using the 35.01. Now I'm going to show you in the next problem how we could do that. Instead of doing 35. We could do it right now. Here's how you can avoid the rounding error if you're willing to do this. 35.01 is just that number right there, right? 50 times tangent 35 degrees. So I could have come over here and just wrote 50 times tangent 35 degrees. And then I could have just waited with that, and I could have put that right here now. So I could have put 50 times tangent 35 degrees and not typed it in my calculator yet. Okay, plus y. Okay, so what am I going to do here? I've got to do that over, that's all over 50, right? Right? So tangent of 47/40, which is this, is the opposite side, which is this plus y, all over the adjacent side, so all over 50. So now, what would I do? I just multiply the 50 over here, so I'd have 50 times tangent. Here's where I think sometimes we get too big a hurry to go to our calculator. Okay, so this would be 50 times this side, and then on this side I'd have 50 tangent 35 plus y. Well, what do I need to do now to get y? Just subtract those. Just subtract 50 tangent 35. So see how you can save, you don't get any rounding now at this point. So now to get y, all I have to type in is, ready? 50 times tangent 47 degrees 40 minutes. Remember how to do that with your degrees minutes? Close the parenthesis, and then minus 50 tangent 35. Close the parenthesis, hit equals. And then you don't have to worry about any rounding error or anything. Right? Instead of getting the 35.01 and then sticking that in there, and then you got to worry about decimal places and rounding and things and wrong values and things like that. Okay? All right, and so whatever you get, that's y, then that'd be the steeple. Make sense? Okay, 32. Designers of a water park are creating a new slide and sketch some preliminary drawings. The length of the ladder is 30 feet. The angle of elevation is 60. Okay, so you got this ladder going up. You got 60 degrees here. Here's the height of the slide, which do they not tell us that? Is that right? That's h. They tell us the ladder is 30 feet. Okay, is that all we got? Yeah. So this is so they've got this line drawn here. They've got, here's a slide going down like so, right? They've got this, they call that theta. We right? Okay, and wouldn't this be H right here? My picture's okay now, isn't it? Okay, all right. So what do they say? Find the height of the slide. Okay, so right there, that's opposite over hypotenuse, so sine of 60 degrees would equal H over 30. So H would be sine of 60 times 30, right? So whatever that comes out to be, okay? B, find the angle of depression theta from the top of the slide to the end of the slide at the ground in terms of the horizontal distance d that the rider travels, the horizontal distance, which would be this distance right here, okay? Well, we found H. H is 30 times sine of 60, right? That's what H is. This theta is going to be the same as that theta right there, right? By alternate interior angles. Okay? So this theta is the same as this theta here. So now we know this. So they said, find the angle of depression theta in terms of the horizontal distance. What that means is they want theta equals and then d's. That's what in terms of means. Okay? Well, what would we have? We would have opposite over adjacent. So we'd have tangent theta equals 30 sine 60, or if you went ahead and got a decimal for that, that's fine. Okay, if you it's okay, that'd be perfectly fine. But I like writing it out just because I don't have to worry about rounding and all that stuff. Over d, right? Now, I would be okay if you stopped right there, but it says find theta in terms of, we know we would just do inverse tangent, so we could do that. You guys know on your calc, we haven't talked about inverses really yet, but what this would be is theta is inverse tangent of, and you just do inverse tangent of this other side like that, and that would be theta in terms of d. Okay, but you could leave it like that, tangent theta equals. Okay, that's what they mean in part B. The angle depression of the ride is bounded by safety restrictions to be no less than 25 and not more than 30. Find an interval for how far the rider travels horizontally. So in other words, we could change this angle here, and so we could plug in some different numbers. I don't know what you have for this, okay, but what did it say? No more than 25 degrees. So put in a 25. So put in a 25 here. So I would do it up here, right? So you could solve this for D. So put a 25 in and put a 30 in. Okay, so just put a 25 in here, solve for D. Put a 30 in, solve for D, and that would be your interval of your distance. Okay, and so. What would that be? That'd just be like 30 sine 60 times 1, divide by tangent 25, right? That'd be D, and then do it again, except put a 30 in there instead of 25. Okay, and that would give you a range of how far D will be. Okay, so that one goes a little up beyond, and we want to be able to do that, right? I mean, you guys are honors. You're honors. Awesome. Smart. So it's good to do just a straightforward, simple problem, which we'll have plenty of those, but how about some where you got to go a little above and beyond, use some algebra. So let's do 26 here together. Let's do 26 here together. And I'm going to do the same thing with this one, where I'm not going to go to a decimal right away with any of those things I've got. So this says that you've got this airplane going along. On number 26, you observe a plane approaching, so you're down here on the bottom right, and you assume, you're watching this plane, and for some reason you're able to assume that it's going 550 miles per hour. Okay, I guess. Yeah. Looks like it. And it looks, yeah, and it looks like the angle of elevation is 16, and
I just can't see that.
and 1 minute later it's 57 degrees. Okay? All right, now, another formula you're going to see quite a bit in the problems we do today and tomorrow. Distance equals rate times time, okay? But now you got to get the right units. So it says 1 minute later. So if it's going 550 miles an hour, how far did it go in 1 minute? Well, that's where that work we did earlier comes in handy. 550 miles in 1 hour. How much is it going to go in 1 minute? 1 hour is 60 minutes, right? So how many miles per minute is it going? Well, what's 550 divided by 60? 9 and 1. Give me a fraction, because I don't want to round. I don't like rounding, especially early in the problem. 9 and 1/6, isn't it? Second in the FD button, right? Use that in the fraction decimal button. Let's use 9 and 1/6. 9 and 1/6 will be okay. So this is 9 and 1/6. Right? If you want to use 55 over 6, you can do that too. Right? If you'd rather write 55 and 55/6, that'd be okay. Okay, but if we round early and then that rounding error is just going to build throughout the problem, and it's going to be a mess. Okay? All right. So, I went ahead and labeled a few things in here. So, let's back up. So, this one, let's call that X. And let's call this distance, we know this is 9 and 1/6 down here to there. But we don't know that. So that'll be Y. Okay? And this is X. Now it seems backwards. Why don't I put my Y on the up and down? Yeah, I could. I could use A and B or, M and N, whatever. You can use whatever you want. Letter, it doesn't matter. Okay, I'm going to call that X, call that Y. I think the question says, what's the altitude of the plane? So we're going to want that, right? We're going to want X. But we have two unknowns here. So in the small triangle here, we got tangent of 16 would be X over these two added together, right? It'd be this plus this. Okay, so 9 and 1/6 plus Y. So tangent would be X over that. And then what about the big triangle here? Well, I say big, bigger angle. Let's do it in blue. What about this triangle? That's why I drew, because that would be X also, right? This would be X right here. So tangent of 57 would equal X over Y. Now, why did I do that? Well, because hopefully you remember from algebra class that when you have two unknowns, you need how many equations? You need two equations to solve two unknowns. Because then we can solve for one and substitute. Remember substitution, linear combination, right? Those things. That's what we got going. So I set up my two, since I had two triangles, usually when you have a problem, it's got two triangles in it. That's why they're there. So you can set up two different trig ratios. Well, I went ahead and multiplied the Y over here and multiplied that over here, and those are both X. Those are both X. So I took this quantity, multiplied it over to this side, and just kept it like that. And on this side, I multiplied a Y over here, and I got X equals Y tangent 57. If they're both equal to X, that means what? If they're both equal to X, they're equal to each other, right? If they're both equal to X, they're equal to each other, okay? So we can just set them equal to each other. So now we have an equation with a Y in it, and now we solve. Now, everybody always freaks out about this, but you've been in algebra. You've been in honors algebra too, many of you. Okay? This shouldn't scare you at all. But, I mean, what do you do if you have 3y plus 7 equals negative 4y minus 8 or whatever? What do? You combine like terms, you get the y on one side. Now, what if on this side it was negative 4 and then it was y plus 2? What would you do? You would distribute. But you know what? So we could distribute right here, right? We could distribute right here. So, yeah. So we distribute, right? It's the same thing. You guys would have no problem if I gave you the equation like this. You would knock that out in a couple seconds. The only difference here is we have this tan 16 in there and a tan 57. So what? That's just a number. Tan 16 degrees, just a number. And maybe you want to get tan 16 and get a decimal. The problem is it would look more like an algebra equation Problem is, it'd be rounded, and then that error, that rounding error would show up probably later in your answer. Okay, so that's why I'm just putting it there, but you just think of tan 16 as a number. So 9 and 1/6 times tan 16, y times tan 16 equals tan 57, okay, like that. Now, what do you normally do? So I know this doesn't look like it, but basically what this problem is right here is 17 plus 2y equals 8y. Well, what would you do to solve that equation? You'd get the y's on the same side, wouldn't you? Okay, so let's do that. Let's subtract the y tan 16. Let's subtract the y tan 16 from both sides, right? Isn't that the same as subtracting 2y in the blue problem? It's the same thing. It's the same thing. So I would subtract 2y. Now, what you guys would do with the blue problem is you would just do this in your head, right? You do 8y minus 2y. Now, what is 8y minus 2y? 6y, but how come it's 6y? Here's how come it's 6y, because you factor out a y, and then you get 8 minus 2. Now, do any of you do that in your head when you do 8y minus 2y? Of course not. But that's what you're doing. That's why 8y, that's why you can add like terms. It's because of the distributive property, right? Now, I know at this point in your career, you just add like terms because you just have memorized that you add like terms, and you just do it. You don't even think about it. But that's why you can add like terms, because of the distributive property. You take out a y, you get 8 minus 2. So what are we going to do on this right side? Hint, hint, hint. We're going to take out a y. We're going to add those like terms. Well, that's what we're going to do. We're going to take out a y. We're going to take out a y. And again, my calculus background a little bit is why I wanted to do this, because there's a calculus, what do I want to say, procedure where you do this same thing, okay? Where you have to do this kind of thing, where you have to gather terms to one side that you're trying to find, you factor out the thing you're trying to find, okay? And now what do we do? What do you do now when you have 17 equals 6y? You divide by 6, so what are we going to do here? We're going to divide by that big mess right there. We're going to divide by that set of parentheses, right? That's just a number. Tan 57 minus tan 16 is just a number, okay? So we're going to do, and it's times by y, so to get the y by itself, we're going to divide by that quantity. So we're going to divide by the set of parentheses. Over there, and then I flipped it around. So we're going to have 9 and a 6 times tan 16 all over that, okay? Okay, and then, whoops, and that's what y is. But what did I want to find? Get lost in the weeds here and forget what we're doing. I just found y. Oh, I just found that, right? What do I want? I want x. I want how high the plane is. How about I come to this one right here? So what I got to do, I got to take y times tan 57. So I got to take y times tan 57. So here we go. So here's my y. There's y right there that I just found. There's y. I'm going to take that times tan 57 because I had set it up early, right? And now I can get out my calculator, and then I can just multiply the top. So now let's do it. 9 and 1/6 with your ABC button. 9 and 1/6 times tan 16 times tan 57. Maybe a good time to hit equals when you do that. Then we're going to divide. Now we're probably going to need to put the parentheses in there. Okay, not probably, we're going to. We're going to divide by this quantity. So we're going to go left paren, and we're going to go tan 57 minus tan 16, right paren. Okay, and hit equals. What do we get? 3.229966. I put all those decimal places just for emphasis, because that I feel confident in the quality of that decimal out to a whole bunch of decimal places. Okay, there's not going to be any rounding error in there. Okay, so when we have our problems, and I say, give your answer the nearest tenth or the nearest hundredth, okay, that means the final answer. So numbers, so you wouldn't have to do this. You could have put numbers in for tan 16 and tan 57. You could have put decimals in, but man, you better put about 5 or 6 decimal places when you write it down. And then when you type it at the end, if you want to get the 1 or 2 decimal place accuracy, you better go out 4 or 5 just to be sure as you go through the problem. If you just round to 1 or 2, you're probably going to lose some accuracy and you're going to lose. Now, I'm going to look at your work and everything has to be partial credit, right? So you can get credit, but you may lose a point if that final answer is not to the right decimal place, okay? So I think there's some value in doing that. All right. So let's get your notes out. Well, that's probably where you're writing. Okay? Now we're not going to do, so we're going to do some more of these, and it's going to have triangles. It's still triangles, okay, that we're talking about, but there's one other concept we got to learn here that some of these problems will use, okay? But they all revolve around right triangles. Everything we're doing is SOHCAHTOA, right triangles. So the hardest part of these is getting the picture drawn correctly. Okay? So we have something called bearing or heading. So in the problems where they say what's the heading or what's the bearing, it's the same thing. Now, this is, if you have a problem with a plane, okay, in air navigation, they do it differently than possibly nautical direction, nautical bearings. So this would be more nautical or on water. You're going to see this. So in the problems that are of that kind, but you'll be given the bearing in one of these 2 different ways, and then you just continue to use that throughout the problem, whichever way you're given. But just understand, if it's air, it's going to be measured one way, and if it's on water, they usually use this. So let's just talk about both of them, okay? So if we say the plane took off at a bearing of 300 degrees, where it's leaving from is that origin right here. And then this is what it's going towards. Okay, so the plane heads on a bearing of 300 degrees. Now it's measured differently than our standard position that we do for our trig functions. Okay, so it's measured from north in a clockwise direction. So 300 degrees would be a northwesterly heading. But if we draw it properly, then we know we're dealing with a 60, and it comes back to reference angles. Okay, but we have a triangle, but we don't have to do the triangle doesn't have to be necessarily from the horizontal. We're doing, in these real life type problems wherever we can draw the triangle. But that would be 60 degrees right in here. This would be 90. This would be 60 right in here. So now we got a 60, and we can answer the question about what's going on. So the whole key to the bearing problems is getting a picture drawn so you can get a triangle. You can get a right triangle, do your SOHCAHTOA with. Once you have the picture drawn, then it's going to be just like the problems you did for today. Okay? All right. Now, in nautical, it's always an acute angle, and it's always measured either east or west from north or south. Okay? So here's 2 examples. So it's always going to have either north or south listed first. Then it's going to have an acute angle. And then it's going to have east or west listed last. So what that is telling you, so when I see this bearing right here of north 20 degrees west, that tells me to go north, right? That tells me north, and then go 20 degrees to the west. West, of course, is towards California on the map, right? To the left. So north, 20 degrees west, that'd be 20 degrees right there. Now, for us, we might be interested in drawing down to here, so we'd have a 70-degree reference right there. Maybe we would rather use the 70, but maybe not. Maybe you would draw a triangle, go up here, because maybe it's this distance, or maybe it's this distance they want, so maybe you would draw your triangle down here. It just depends on the problem. Okay, if they say south 50 degrees east, that means go south, and then go 50 degrees towards the east. East is to the right on the map. Right? So south, so go south first, 50 degrees east. Now, we could have two cities that would have two different bearings. So let's say this is Kearney, and let's say this is Broken Bow. So what is the bearing if you were going to leave from Kearney to Broken Bow? Well, that's 300 degrees. What would be the bearing if you left Broken Bow headed to Kearney? Well, now you have to draw your XY axis at Broken Bow, because Broken Bow is where you're leaving from and going towards Kearney. So now the bearing to go from Broken Bow to Kearney would be that angle. Well, what would that be? Well, we already said this was what, 60?
Yes.
So what's this? What's that?
Wouldn't that be 30 degrees?
Where?
Right there. Because it's 60 would be the other.
Yeah, that's what I'd said. Yeah. Thank you. 30, because this is 90, 180, 270, and then you got 30 more to 300. So yes, you're right. So this would be 30, and this would be good. I'm glad you didn't let everybody go to lunch wondering that. Thank you, Jim. Seriously. 30 degrees, yes, it is. Okay, and then this is 60 here, so what would be the bearing if you turn around and leave Broken Bow and come back to Kearney? 90, so if this is 60, what's this? 30 in there, so 90 and 30, so 120. So from Kearney to Broken Bow is a bearing of 300. From Broken Bow heading back to Kearney, it's a bearing of 120, right? So it's where you're going from to where you're going towards. Okay, we'll pick up from there. All right, here we go. If you want to turn to page 359 in your book, 359. Hey, don't forget on the website, I don't know if anybody's been using this, that Calc Chat. It's just the odd numbered exercises, but you can go on to there and you can, I think the link I have a link that takes you right to our book on the website. Under the links, one of those things over there. But it's the odd problems, but they're worked out. There's some steps maybe of things worked out. So maybe that's something that can be useful. I know you have the answers to the audience in the back anyway. All right, so we were talking about this bearing. So bearing or heading, and again, if the problem is given, if it's an error problem, it's probably this kind of a bearing. And you can obviously tell the difference because you don't have any direction given. If there's no direction, south, north, that kind of stuff given, then it's the first type over here. If you're given this, then it's that type. And that's the bearing you want to use, okay, if they ask for a bearing in your answer. But a lot of times they don't. Okay, so basically, one last thing for your notes. So if you're talking about on the water, you'll sometimes have this unit where it'll say, well, the boat's moving at 20 knots. That's nautical miles per hour. So it's just miles per hour. I mean, if we're concerned, just think of it as 20 knots. Think of it as 20 miles per hour. Okay, so just speed. So in some of these problems we're given that, like the one we just talked about. Okay. All right, so basically here's the homework. What we're going to do is we're going to work through these book problems together for a while here. I think maybe just going through some together is good. If you want to, though, if you're faster and can get more done than just following with us and want to work ahead, that's fine. Okay? So they're just I was going to say a handful of problems. It's several handfuls. But anyway, so practice, right? Okay. So, of course, we're going to be at basketball practice still. But anyway, before then, we can get them worked on them during the freshman. All right. So anyway, so 359. Let's start with number 34. Okay. And like I said, you want to,
you know, if you can work ahead, that's fine, but I just thought we'd go through, as many as we can here. During takeoff, an airplane's angle of ascent is 18 degrees, and its speed is 275 feet per second. So, okay, so just, and I think pictures, one of the things I was looking for when I came around today looking at homework was pictures, right? I think you should draw triangles as much as is humanly possible. They do not need to be to scale. So its ascent is 18 degrees. That'd be like angle of elevation. What's the altitude after 1 minute? So again, we got this 275 feet in 1 second. So in 1 minute, you would multiply that by what? 60? Because there's 60 seconds in 1 minute. So that would be feet per minute. So 275 times 60. Go ahead and do that. What do you get? How much?
Oh, that was bad. I did 63.
So 275 times 60.
16,500.
Now where does that go? Hypotenuse or down here? It is the hypotenuse. What is it? 16?
16,500.
Okay, now, I don't know if we're going to run into any of those problems, but sometimes they'll say airspeed. If they don't say, so we're going to assume that the 275 feet per second is airspeed versus ground speed, right? Ground speed would be, as it's flying, how fast is it covering horizontal distance, okay? But we're going to put the 18, or put the 16,500 up here. Okay, so which trig function are we looking at? Sine, right? Opposite over hypotenuse. So sine of 18 degrees is x over 16,500. I don't care if you just stop with that and then go to your calculator right now. It's going to be, obviously, 16,500 times sine of 18. I do want you to set up your original equation. I want you to set up the sine. So like on the test, I want to see sine 18 equals x over 16,500. But from there, if you can just in your head say, okay, hey, I'm going to multiply there, and then just do it on your calculator, I'm okay with that. Okay? And that would be the altitude of the plane. What do you get? 5,000. $98.78. Okay, so we can go with that for. I'll probably try to give you some direction on how many units we said. If we don't hear different, let's do 2. Okay, 5,098.78 feet. How long will it take the plane to climb to an altitude of 10,000? Okay, well then we would have what? We'd want x to be 10,000, right? So then you've got, and you don't know this, right? We don't know this because it says how long will it take. So first, how many feet would it take? Okay, and then we can figure out how long because we know it's going 275 feet per second. This was in 1 minute, so we don't know this number anymore. So now we know this is 10,000. Okay, so now we probably should use something other than x, but it's still tangent. So tangent of 18 degrees is 10,000 over, what I say? Oh, I don't know why I said 10. Geez, I'm having struggle. Ever since I messed up that 30 degrees for lunch. Oh, no way. So yeah, still sine. Opposite over hypotenuse. So sine of 18. Now remember, here's where you can think cross multiply. So 10,000 times 1 divided by sine 18. So it's 10,000 divided by sine 18 is x, right? 1 times 10,000 divided by sine 18. That gives you x. Always in a cross multiply kind of scenario. Okay? And what do you get there? Something about 117 something? Oh, no, never mind. That's not what you get. That's feet. What do you get?
360.
Okay, and then what are we going to do to get that into how long that takes? Divide by
6.
Don't we have to go here? Okay, so let's write it down. What do you got? What do you got? Let's write out 32, you said? 360.6. Okay, so you can keep that in your calculator. okay, and that's feet, okay? And we want to know how many seconds. Well, it's going 275 feet in 1 second, right? 275 feet per second. So we've got this many feet was the hypotenuse. So I want feet to cancel. I want to end up with seconds. Now you could turn it into minutes. You could divide by 60 to get minutes if you want, but I think seconds would be fine. So feet cancel feet. So that divided by 275, what do you get? 117.67 seconds. Which is not quite 2 minutes, but okay, so I mean you can divide by 60 and get it in minutes if you want. And maybe the direction would say, if it doesn't, you can just pick your units. I don't care about that. Okay? Alright, so there's an example. Okay? I mean, there's just a lot of different things. I want to get into a couple that have this bearing and stuff in them. So let's go navigation here, number 35. An airplane flying at 600 miles per hour has a bearing of 52 degrees. After flying for 1.5 hours, how far north and how far east will the plane have traveled from its point of departure? Okay, you draw the picture. Has a bearing of 52 degrees. So which of these bearings are we using? The one on the left or the one on the right? The one on the left, because it didn't give us any north-south stuff, right? It just said 52 degrees. So we're doing the one on the left. Okay? 52 degrees. It's always measured clockwise from north. Right, a bearing of 52 degrees, so it's from north. How far north and how far east will the plane have traveled? So that tells me I'm going to want my triangle to come down here. And I'm going to want, there's X and there's Y. That's going to be how far north and how far east. So I'm going to be two answers, right? X will be how far east and Y will be how far north. Okay? So what do I know, though? I need another piece of information. I know the hypotenuse because it's going 600 miles per hour and it's going for 1.5 hours. So what would that be? 900 miles, right? 600 miles per hour times 1.5 hours. So 900 miles is how far. So that's at distance equals rate times time, right? So they give you a time or give you a rate, and then they say they've been going for this many hours, and you can just multiply. Now, you can set up your units and get them to cancel too. That's fine. But it's going to be, you know the hypotenuse is 900 miles. Okay? So to find X, what do we use? Find X. Cosine, adjacent over hypotenuse. So cosine of 38 is X over 900. So all you have to do is multiply by 900. And sine for the other one. Sine 38 degrees. Y over 900. They're not that hard. Once, you just got to go slow and don't make no mistakes like I've been making. And get the picture. I mean, really the hardest part is to get the picture. And so just read the question until you have an idea of, of what's going on, and carefully draw your picture. And once you have the picture drawn, then it's pretty straightforward. Okay, something 550 some miles north and 709 or something miles east. What did I say, 554? Yeah. 554 north, 709 east. I mean, approximately. I mean, again, you're just going to multiply these by 900. That'll give you your X. Okay. So we went through that really kind of longer one with the two equations. We had to set them equal to each other, So you may run into something like that every once in a while. Most of them will be pretty straightforward. Okay? So don't make them harder than they are. All right, 36. And I want to see at least, so what I've been trying to put down on the screen is what I'd want to see on your paper. If this was a test question, from here, if you do the rest on your calculator, that's good. But I want to see that initial setup written down. Okay, 36. A jet leaves Reno, Nevada, is headed towards Miami at a bearing of 100 degrees. The distance between the two cities is approximately 2,472 miles. Okay, so draw yourself a picture. Jet leaves Reno, headed to Miami at a bearing of 100. Okay, what's my angle there then? What would this angle be right here? 10. Right, so 100 degrees again from north, so 100 degrees, and that seems right? Miami would be south and east of Nevada, so 10 degrees there. And what's it say? The distance between them is 2,472, so that's this. So isn't that pretty much the same problem so far? It says how far north and how far west is Reno relative to Miami. So again, Miami's here, so north would be this far and then west. But again, that's the x and the y. And isn't it the same thing? It's a cosine and a sine, right? Same setup we just had. It's a very, very similar problem. Cosine 10 degrees would equal x over 2472, and sine of 10 degrees would equal y over 2472. And then you just multiply those. I've got this written in my book, but I don't know if that's... It's mostly west, right? I mean, Miami's east, a long ways east, and a little bit south, depending which one you're coming from, right? So just typing those in, making sure we're in degree mode, right? We're almost always in these problems in degree mode, right? Real life triangle problems, real life kind of triangle problem this way. But now, and then we talked about this for lunch, if you want to return to Reno, what bearing do you leave Miami? This is part B. What bearing should you travel? Well, that's where you got to come in here and put an XY axis here. And where are we drawing? From north to there, right?
Be the same thing as just extending the hypotenuse.
This one here?
Yeah.
Yeah. Yeah, right, because that's the same heading, right? So from Miami to Reno, so you could go here, you could come all the way through here and then draw around to that. It'd be the same thing. It's the same picture, yes, exactly. And that's fine. That's fine if you do that. I just think to avoid confusion, it's nice to know, okay, in my bearing, I'm going from this destination to, and then we put our axis at our origin, or at the, originating location. But it would be the same, yes, if you extend it through. Okay, so what is that? This 10 would be the same as this 10 down here, right? Because of the alternate interior, so that's 90, 180, 270, 280, 280 degrees. 280 degrees would be your bearing to head to Reno. Okay? Which makes sense. 100 degrees puts you down into this quadrant, which is south and east. 280 puts you up into this quadrant, which is north and west, which should be what happens. Okay, 37. A ship leaves port at noon and has a bearing of south 29 degrees west. The ship sails at 20 knots, which remember is 20 miles per hour. Okay, leaves port at noon with a bearing of south 29 degrees west. So go ahead and draw that. How many miles south and how many miles west will the ship have traveled by 6 p.m.? And again, if you're wondering at all which quadrant you should be in, I mean, it says south and west, I mean, right? So it's southwest. I mean, so it's going to be down in that, it's got to be down in that third quadrant. The key, though, is the 29 goes here. I mean, that's probably the key thing you got to remember. So that's why I like to think it's going to go south, and then it's going to go 29 to the west from there. So from south, it's going to go 29 degrees, okay, which is totally, we would never do that when we're doing reference angles and we're doing trig in standard position. We would never draw an angle with the vertical like that, right? But this is a different situation. Okay, so it's going 20 miles per hour. So by 6 p.m., it's been going how long? 6 hours. So 20 miles per hour for 6 hours. What's that? 120. Went 120 miles in that direction. And it wants to know how many miles south and how many west. So again, we're looking at this triangle here. This would be the west, and this would be the south. So if this is 29, what's this angle in here? Yeah, we could use that. That 29 would be here. So you could use that, you know, if you wanted to. You could use that 29. We're so used to putting them in here. So what would that be, 61? 61? So it doesn't really matter. You could, if this is 29 up here, this would be 29 here. And you could draw it down here. I mean, I could draw the red triangle. I mean, there's nothing, I guess I like drawing it where we're used to drawing it, but I could draw this red triangle right here. And this would be the south, and this would be the west, right? So you could do that. There's nothing wrong with that. For these problems, that's fine. Okay? I just like drawing the other ones because then it stays consistent with what we've done before. So it's going to be sine of 61 degrees would be y over 120, and cosine of 61 degrees will be x over 120. But again, you could do sine of 29 would be x over 120, and cosine of 29 would be y over whatever. But you're going to find those values there. So the 58.18, does that sound right? 4.95. At 6 p.m., the ship changes course to due west. Find the ship's bearing and distance from the port of departure at 7 p.m. So it's headed here, it gets to here at 6, and then it heads straight west for an hour. How far did it go? 20 miles. Now, what's it want to know? It now wants to know from the port, which was here, what's its bearing? So we need to know, well, we're going to give the bearing in the same the same way it's given. So the ship's bearing and distance. So what do you think now? Well, what do we know? We know y is right, and we know that. Okay, what else? We know what x is, 58.18, right? Wasn't that the last one? So now we add those two together, so we know this side of this. So now the blue triangle, we know this is 78.18. Now I'll be honest, I'd rather that be 20 plus this because of rounding right now. So I would rather call that 20 plus, and then that was 120 times cosine of 61 degrees. Okay, that's this side here. And so now the angle we don't know. So here's where we're going to do that second, and then what, tangent. So we have opposite over adjacent, right? So tangent of theta, we don't know what theta is here, but we know it's this. Now if you want to use a 78.18, if you have more decimal places, that would be good. If you really were going to be careful about it, you could do that. 20 plus what x was, and remember x was up here, x was 120 times cosine 61, so that can be on top, and then the bottom is the 104.95, and again, what was that? That was 120 times sine 61, okay? So I'm going to write down 78.18 and 104.95, but I'd probably like to go backwards on my calculator and see what those numbers were with longer, with more decimal places, okay? But this is where we hit second tangent, and then divide that. So second tangent of 78.18 divided by 104.95, and what do you get for the theta? $36 point something? Point what? 68. Okay. We'll go. On degrees, we probably would go one decimal. Let's just say it's 36.68. Now, how are we going to write that? So it's the same as what the problem was given to us originally. South 36.68 degrees west, because it's south and then west that many. Yes?
Can you explain again why we use second tangent in that case?
Because you can't, because here you would just go sine 61 and cosine 61. Okay? You can't do tangent of this because it is a tangent. It's on the other side of the equal sign. It's kind of like this. It's kind of like the same reasoning if I got 3x equals 18, right? Or I had x equals 4 times 7. Well, on this one, I'm just going to do 4 times 7 because they're on the same side. It says times. Okay, so they're on the same side. It says do sine of 61, so I do it. This one, and trust me, I taught Algebra 1A long enough and Algebra 1B where students say, oh, it's times, so they take 18 times 3. Well, you can't take 18 times 3 because they're not on the same side of the equal sign, right? You got to undo the 3, right? And how do you undo it? You do the reverse. So you do the inverse of multiplying, which is dividing. So you divide by 3. So what we're doing is trying to undo the tangent from the theta, and that's what inverse tangent does. That help at all? Okay. It's on the other side, so we're trying to get that theta by itself. So we're trying to undo tangent, and that's what inverse tangent or second tangent does. Okay, so yeah, I should have written that. So basically what you're typing is inverse tangent, and then that right there.
So we use the inverse whenever we don't have the
theta. When you don't have the theta, that's when you do the inverse. Exactly. Okay, when they're right together, when it's cosine 61, sine 61, they're right together, that's when you just type it in just like that. Okay. All right, so that's about as much as we have time for. So you got a few more there to finish out, and then you got a few on this worksheet. Now, tomorrow's going to be a fair amount of work time. There's nothing new to do tomorrow.
other than answer your questions, okay? I don't want you staying up till 2 in the morning to get all this done. So if, if it's getting to be 1:30 or so, put it away. Put it away, okay?
We'll just call you with our questions.
At 1:30.
FaceTime.
Yeah. If you have questions after 9 o'clock, then, yeah, forget about it. My phone will be on Do Not Disturb and I will be in bed. But, okay? So omit, yeah, it said omit, 5 on the first side, the 3-2 side. Omit, 8, I'm sorry, omit 8 on the 3-2 side. And omit 5 on the other side.
Which 5?
Okay?
3-2 is
No,
8.
like,
It's,
Boy.
you're saying like.
omit 8 of them, yeah, in the front. So omit 8, there's 9 questions, omit any 8 you want.
Please.
Okay, so tomorrow, answer some questions about that. I'll have a worksheet with some more of the triangle problems, and then also some back of the book or back of the chapter review for the test. So it'll be a lot of work time, okay?
I'll be gone for the second half of lunch.
All get your shit done right.
Yeah, because I know with test on Thursday, I know intramurals again Wednesday. Yeah, so. That's why I gotta give you some work time. I gotta give you some work time during class. I have time during intramural. So, Get X-ray. So yeah, it's wrong. She sent me some pictures of her Friday. Avery. So yeah, he said it's doubtful. So next man up.
I don't know. So does that mean I'm like point guard or like
Yeah, I don't know.
I go point guard?
Maybe.
I can make
You don't have fourth line class?
I have actually, but.
Okay, as long as you ask her permission. Tomorrow, 4 o'clock, he's ready.
And then was there a worksheet on Friday?
Yeah, I think there was. We skipped those 2. Okay? Let's see, was there also this one? I think there was this one that day too, just finding the reference angle. It handed in or anything, but just practice. Okay? Janae, is this it? Is today the day?
Yeah, I need to go to 3 places though today.
To what?